Hello, this is a review for test number 1. I'm going to go over every problem. I'm going to have to go real fast because I do have a time limit on this recording, so I'm going to have to go fast. Numbers 1 and 2 is nothing more than order of operation. Remember PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. So we have addition and multiplication here. So we do the multiplication first. So that's 5 plus 12 is 17. I'll give you a little hint here. You can put this in your calculator and it'll do order of operation for you. Number 2 is 3 plus 4 squared minus 12. And again, we would do the exponent first. So this is 3 plus 16 minus 12. 3 plus 16 is, was it 19? Minus 12 is 7, I think. Number 3. Number 3 is solve for the given variable. R-I-A-B-L-E. So if we have, I know this is real simple for a lot of you, but sorry, I'll do better next time. Okay, 3 times A equals that. How do we undo multiplication? Division. We divide everything by 3. And that gives us A equals, now a negative divided by a positive is a negative, and that's, I think, 4. Number 4. Same thing, solve for the given variable. If we have 5C plus 4 equals 3C plus 10. Now, what we want to do here is we have variables on both sides of the equation. Move the smaller number of variables to the other side. Think about them like a load of bricks. So subtract 3C from each side, and we get 2C plus 4 equals 10. Now we move the 4 over here. Just do the opposite of whatever it says. If it says plus 4, subtract 4. Whatever you do to one side, you have to do to the other side. So you have 2C equals 6, divide by 2, C is 3. And if you want to double check, you can plug it back in and see. Number 5 is evaluate with all positive exponents. And remember, if you have a negative exponent, move it. If it's in the top, put it in the bottom. If it's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. So if we have d cubed times d to the 5th, remember when we have the same base number, these are the base numbers, the big ones, and we're multiplying, you add the exponents. Again, same base numbers, we're multiplying, so we add the base numbers as d to the 8th. Number 6. E to the negative 4th over, I hope my big fat hand, look how old my hand looks. Oh God. E to the minus 4 over G to the minus 2. Okay, when the exponents are negative, move them. If I were you, I would draw my fraction bar first, and then just take them one at a time. Okay, e to the minus 4, so that's going to go to the bottom. And then the exponent becomes positive. Okay, move it and it becomes positive. G to the minus 2 goes up and it becomes positive. Let's see, what else do we have? And this is about as difficult as these get, is number 7. Oh, come on. Number 7 looks like this. If you have 3k to the 4th over 5k to the minus 3rd, all raised to the negative 2 power. This is called the power rule. We take all of the exponents inside. When you have, when you have the power rule, you multiply all of the exponents by this one. Okay, so this is going to be equal to 3 to the minus 2. Remember, there's an exponent here. We just don't write it. And k, and again, you multiply the exponents when you have a power rule, power raised to a power. That's k to the negative 8. Negative 2 times 4 is negative 8. Same thing here. 5 to the negative 2. And k, negative 2 times negative 3 is a positive 6. Okay, draw the fraction bar. Take these one at a time. 3 to the minus 2 goes to the bottom and becomes positive. K to the minus 8 goes to the bottom and becomes positive. 5 to the minus 2 goes to the top and becomes positive. K to the 6, this one's already positive, so it stays where it is. 5 squared is 25 over 3 squared is 9. Now we have same common base numbers, the same base numbers, and we're multiplying here. It doesn't say anything, but if there's not a plus or minus in here, we're multiplying. And k to the 8th times k to the 6th is k to the 14th. Can't reduce the fraction. Well, that's all there is to that. Okay, that was number 7. Now number 8 is evaluate USING. The distributive property of multiplication. Very, very important. So if we have 7, this is number 8, by the way. 7 open to a plus 5. Take the 7 and multiply it by everything in here. That is 14a. 7 times 2a is 14a plus 35. Is there anything else we can do? No, not like terms. Number 9. And again, I'm sorry to go so fast here, but 3b plus 2, 3b plus 2 times 4b plus 5. Okay, 3b times 4b, first we take the 3b and multiply it by everything over here. And that's, what is that, 12? B squared, because b times b is b squared. And then 3 times 5, excuse me, plus 15b, right? I hope that's right. Okay, now we do the 2 times everything over here. 2 times 4b is a positive 8b plus 10. Middle 2 terms are common. So we have 12b squared. 15b's and 8b's are 23, I think. 23b plus 10. Is there anything else we can do? No. Number 10. stupid boy. Okay, factor the following trinomials. Number 10 is x squared plus 6x más 8. Okay, now remember what we do is we take this, the 8, and factor it. Everything in here is positive, so it's going to be x plus some number and x plus some number. Now, what are the factors of 8 that add up to, because everything in here is positive, so we're going to add everything, that add up to 6. 1 times 8, 2 times 4, that's it there, isn't it? 2 and 4. Right? Right. Let me see, we're 11 minutes. Number 11 is y squared minus 10y plus 24. Okay, now the middle term, the linear term, is negative and the constant is positive. Therefore, I'm sorry, let me move my camera around. Okay, so if the linear term's negative and the constant is positive, both of the terms are going to be negative. Because, remember, the last thing we do when we do distributive property is this number times this number. Negative times a negative is a positive. So we want the factors of 24 that combine together to give us 10. Negative 1 times negative 24, no. Negative 2 times negative 12, no. Negative 3 times negative 8, no. Negative 4 times negative 6, yes. 4 and 6. And if you want to double check and make sure, negative 4 and negative 6 is negative 10. And negative 4 times negative 6 is positive 24. So we are correct. Number 12. W squared plus 3w minus 40. Now what we have is, excuse me, the constant is negative, the linear term's positive, so we're going to have w plus some number and w minus some number. Because remember, when we're doing distributive property, this number times this number is going to be that one. So we want the factors of negative 40 that combine together to give us 3. So we have negative 1 times 40, no. Negative 2 times 20, no. Negative 4 times 10, no. Negative 5 times 8, 5 minus 8 is positive 3. So we have a positive 8 and a negative 5. Number 13. What could be more fun than factoring? Oh my goodness. Oh, wait. You know what? Before I forget, I'll do it after this one. 6x squared minus 8x minus 8. Okay, what we want to do here is, excuse me, 6 times 8, a times c. 6 times negative 8 is a negative 48. Y'all remember from 4th grade how 6 times 8 is 48? Kind of rhymes, huh? Okay, we want the the factors of 48 that combine together to give us negative 8. And we're going to split this linear term up into two factors. So negative 1 times 48. Actually, let's do it backwards because our linear term is negative. So the bigger number is going to be, so rather than that, we'll do 1 times negative 48. No. 2 times negative 24. No. 3 times, come on, stupid, times negative, was it 16? No. 4 times negative 12. That's it there, isn't it? 4 minus 12 is negative 8. So which one do we want to put next to the 6, adjacent to the 6, and which one do we want to put adjacent to the negative 8? So let's do 6x squared minus 12x plus 4x minus 8. Now we do groupage. Sounds nasty, doesn't it? Groupage. Okay. Now what factor can we take out of, or what can we factor out of both of these terms? 6x, right? X minus 2. 6x times x is 6x squared. That's right. 6x times negative 2 is negative 12x. We're right there. And what can we factor out of the second one? 4, huh? 4 open x minus 2. Remember, these two terms have to be the same. If they're not, we've done something wrong. So we have 6x plus 4 times x minus 2. Okay, wasn't that fun? That's good stuff, huh? Okay. Okay, 14 and 15 are basically the same thing. If we have the difference of two squares, Q-U-A-R-E-S. For instance, if we had 9y squared minus 25. Are these two things perfect squares? Yes. So this is going to equal 3y plus 5 times 3y minus 5. Now also, if we have the sum of two squares, they are prime. So if we had 9y squared plus 25, you cannot factor this. This is prime. Okay? Evaluating lowest terms. This is number 16. Square root of 6 times the square root of 7. That is the square root of, what is that, 42? And just leave it like that. $17. The square root of 9 over the square root of 36. Okay, square root of 9 is 3. Actually, it's plus or minus 3 over 6, which is 1/2. Don't forget to reduce these fractions or get your, oops, sorry. when you take a drink of your Diet Coke. 18. The square root of 100. And we need to factor this into two terms or two factors, excuse me, where one of the factors is a perfect square. This is the square root of 25, which is a perfect square, times, oh, wait a minute, that's not right. Oh, stupid. I gave you the wrong thing. Bonehead. The square root of 75 is the square root of 25 times, 3? Now, when you take the square root of it, you can break it down into two different ones, like that. Now, the square root of 25 is 5. Once you take the square root of it, it comes out of the radical, times the square root of 3. 19. The square root of x squared. What number times it? Remember the fraction bar. The radical means what number times itself. What number times itself is x squared? X. Number 20. H to the 7th. Remember, when we're doing square root, we have to have an even number here. Because actually what you're doing is dividing that by 2. So we need to factor this into square root of h to the 6th times the square root of h. H to the 6th times h is h to the 7th. Now take the square root of, excuse me, h to the 6th is h cubed. H cubed times h cubed is h to the 6th times the square root of h. There's nothing you can do there. 21. Square root of negative 64. Okay, remember when you have the square root of a negative number, you're going to bring out an I times the square root of 64. Now the square root of 64 is 8. Oh, can you be more stupid? It's 8I. Sorry, I'll do better. Ooh. 22. The square root of, no, not that, negative 32. We can go ahead and bring out the I times the square root. Now we're going to factor this into two factors where one of them is a perfect square. So it's 16 times 2. Right? Square root of 16 is 4. We have 4i. Square root 2. Okay. Number 23. If you have 5 plus 3i times 5 minus 3i. What do we have here? We have a conjugate, right? The numbers are exactly the same, except one's a plus and one's a minus. And remember that the square root of negative 1 is I, and I squared is negative 1. Okay, so now this is nothing more than distributive property. 5 times 5 is 25 minus 15i, right? Now we do the 3i. 3i times 5 is a positive 15i. And 3i times negative 3i is a negative 9i squared, because I times I is I squared. Middle two terms are opposites, so they eliminate each other. So we have 25 minus 9, right? Now I squared we know is negative 1. So this is 25 plus 9. Negative 9 times negative 1 equals 34. Right? Right. Okay, 24. Calculate the length of unknown side. Known. If you have and assume the triangle is a right triangle. A and x. And Pythagorean theorem says a squared plus b squared equals c squared. Our a is, remember these are a and b. Doesn't make any difference which one's which, but this one must be c. The hypotenuse, the one that's opposite from the right angle. So we have 6 squared plus 8 squared equals x squared. 36 plus 64 equals x squared. 100 equals x squared. Take the square root of everything, so x is 10. Does it make sense? Is it reasonable? Is it the longest side? Yes. 25. Distance. Find the distance between the 2 points. And the distance formula, lowercase d, is the square root of x2 minus x1 closed squared plus y2 minus y1 closed and squared. And remember, points are always in the form xy. So what is the distance between 5, 3 and 8, 7? Remember, they're always in the form xy. This is the first coordinate, so we're going to call it x1, y1. This is the second one, so it's x2, y2. And so our distance is x2, which is 8, minus x1, which is 5, closed squared, plus y2, which is 7, minus 3, closed squared. Now it's just order of operation. We do square root of 8 minus 5 is 3, plus 7 minus 3 is 4 squared. So we do the square root of, and that's 9 and that's 16, the square root of 25, which is 5. Right? Right. And solve the quadratic. I'm running out of time here, so I'm really having to hurry here. I'm sorry. Okay, so solve the quadratic. If you have d squared minus 11d plus 26 equals negative 4. Now remember, the first thing you want to do is to set this equal to 0. So we're going to add 4 to each side, and we end up with D squared minus 11D plus 30 equals 0. Now, what are the factors of 30? Now, the linear term's negative, the constant's positive, so it's going to be D minus something and D minus something. So the factors of 30, 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Actually, they're negative, all negative numbers. Okay, -5 and -6. Right, equals 0. Now we set each one of these equal to 0. Stupid boy. So D minus 5 equals 0, and D minus 6 equals 0. Add 5, add 5. So D is 5. Add 6, add 6. D is 6. And there we have it. That's it. Best of luck on the test. Take care. Bye-bye. Bye, Bonds.